Most developers can build apps, but they get stuck when it comes to payments. In this video, I will show you how to add Stripe payments in your Next.js app from scratch. We will go from products to cart to checkout, and after a successful payment, the order will be saved in your database automatically. No theory, just real implementation. Let's get started. Alright, let me quickly show you what we are building. This is our products page. Here you can see all the items. Now let's add some products to the cart. I will add a few items, and if I open the cart, you can see all the selected products here. And on the right side you can also see the price breakdown. We have subtotal, GST and delivery charges calculated automatically. Now let's go to checkout, and as soon as I click on checkout, it takes us to Stripe's secure checkout page where the user can enter their details and complete the payment. Now I will enter the test card details and click on pay. Perfect, payment is successful. Now the important part, if I go to our database, you can see a new order is created. So yeah, this is the complete flow we will be building in this video. Now let's start building this step by step. I have already created the products page along with the cart functionality so users can add items and manage their cart. But right now if I click on checkout, nothing really happens. So in this video we will focus on the payment integration part using Stripe and how to handle everything on the backend. We will create the checkout flow, integrate Stripe and finally store the order in our database after a successful payment. First, let's go to Stripe dashboard. If you don't have an account yet, you can sign up. It's completely free. Once you are inside the dashboard, I recommend creating a new account for testing. So I will create a new business account. Click on continue and I will skip the steps for now and go directly to the sandbox. Now inside this account, you will see your dashboard where all your test payments will appear, and on the right side you can find your API keys. We will be using the publishable key on the front end and the secret key on the back end. Now copy the publishable key and paste it inside your .env file as next public Stripe publishable key. Next, copy the secret key and paste it as Stripe secret key. Now install Stripe. Next, let's create a checkout API route. This route will handle creating a Stripe checkout session from the backend. First, let's import Stripe. Then we create a new Stripe instance by passing our Stripe secret key from the environment variables. Next, we create a post function and accept request as a parameter. Inside this, we use a try catch block. In the catch block, we simply log the error and return a response using next response. Now, inside the try block, we extract the items, basically our cart items, from request.json, which we will be sending from the front end. Next, we create a Stripe checkout session. This is the core part of the integration. Stripe will use this session to handle the entire payment flow, including the checkout page and payment processing. Inside the session, we first define the payment method types and set it to card, so users can pay using their debit or credit card. Next, we enable billing address collection and set it to require. So Stripe collects the user's billing details during checkout, which can be useful for orders and records. Next, we add the line items, which will be displayed on the Stripe checkout page. Inside line items, we loop through the items that we extracted from request.json. For each item, we define the price data. Here we set the currency to INR. Then inside product data, we pass the product name, which will be shown on the Stripe checkout page. After that, we set the unit amount by multiplying the product price by 100 because Stripe expects the amount in the smallest currency unit. And finally, we pass the quantity of each product. Next, we set the mode to payment to indicate that this is a one-time payment. Now, let's add the success URL and cancel URL. So if the payment is successful, it will redirect us to the success page. And if the payment fails or is cancelled, it will take us back to the cart page. First, let's add the success URL. I have already created a success page in the project, so I will go to .env file and add the base URL as localhost. Now using that, we set the success URL, and similarly let's add the cancel URL, which will redirect the user back to the cart. Finally, we return the session URL as a response. This URL is the Stripe checkout page, which we will use on the front end to redirect the user. Now let's quickly assign a type to the item so all the TypeScript errors are resolved. So now our checkout API route is complete and ready to use. Now let's go to the cart page. So this is my cart page, and here you can see the payment details along with the checkout button. Now let's use our checkout API route. In this project I am using React query, so I will use mutation to handle this action. Now let's write the mutation. Here I am using use mutation from React query. I am extracting mutate as checkout and also getting the is pending state. Inside this we define the mutation function. In the mutation function, we make a post request to our checkout API, and we send the cart items from the front end. Once the request is successful, we get the response. And inside the on success, we redirect the user to the Stripe checkout page using the URL we received. And in case of any error, we simply log it in the console. Now let's attach the checkout function to the button. So when the user clicks on the button, it will trigger the checkout process. Next, we will conditionally render the button text based on the is pending state. If the request is in progress, we show processing, otherwise we show checkout. And finally, we disable the button when is pending is true. So while the request is being processed, the user can't click the button multiple times and send duplicate request. Now let's go to the browser and test this. As you can see, we already have some products in the cart. Let me quickly increase the quantity and click on checkout. And you can see it takes us to the Stripe checkout page. On the left side, you can see all the products with their name, price, and quantity. And on the right side, we have the payment form where the user can complete the payment. Now, you might have noticed that GST and delivery charges are not included here, even though they are visible in our payment details. The reason is we are not sending them to Stripe as line items yet. Right now, we are only passing the product items to the checkout session. So, to include GST and delivery charges, we need to send them from the front end in our mutation and then handle them inside our checkout API route. Now, let's also extract GST and delivery from request.json, and inside line items, we will add them separately. First, let's create the price data for GST. We set the currency to INR. Then inside product data, we set the name as GST 18%, which will be visible on the Stripe checkout page. After that, we set the unit amount by multiplying GST by 100, because Stripe expects the amount in the smallest currency unit. And finally, we set the quantity as 1. Now for delivery charges, we can simply copy the same structure. Just change the name to delivery charges and set the unit amount to delivery multiplied by 100. Now let's go back to the browser and test this again. And you can see now GST and delivery charges are also included. Now let's fill in the details and complete the payment. And there you go, we are redirected to the success page, which means our checkout is working perfectly. So up to this point, we have successfully implemented the checkout flow. But we are still missing a very important part. Right now, we are not storing any order data in our database. We don't know which user placed the order or which products were purchased. So to solve this, we will use Stripe webhooks. With webhooks, Stripe will notify our backend whenever a payment is successful. And at that point, we will create the order in our database. So next, let's set up a Stripe webhook and handle that logic. Before creating the webhook, let me quickly show you the order schema. I have already created these tables in Supabase. So we have an order table which stores fields like ID, status, total amount, user ID and the Stripe session ID. And then we have order items which stores the individual products inside each order, including product ID, quantity and price. So now let's create a webhook API route. This route will listen to events sent by Stripe after a payment is completed. First, let's import Stripe and create a new Stripe instance using our Stripe secret key. Next, we create a post function and accept the request as a parameter. This function will handle all the webhook events sent by Stripe. Inside this, first we read the raw body from the request using request.text. We do this because Stripe requires the raw request body to verify the webhook signature. Next, we get the headers, so we can access the Stripe signature sent with the request. From the headers, we extract the Stripe signature. Now we add a condition. If the signature is not present, we return an error response because without the signature, we can't verify that the request is coming from Stripe. Next, we define an event variable. Then we wrap everything inside a try catch block. In the catch block, we simply log the error and return an error response. Now, inside the try block, we construct the Stripe event using the raw body, the signature, and the webhook secret. This step verifies that the request is actually coming from the Stripe and hasn't been tampered with. For now, don't worry about the webhook secret. We will add it later. Once everything is verified, we check the event type. If the event type is checkout.session.completed, that means the payment was successful. And inside this condition, we create the order in our database. So first we get the session from the event. We will use this session to access the line items and also the session ID which we will need while creating the order. Next we need the user ID. We will get this from the checkout session metadata. Now you might wonder why not get the user directly inside the webhook using auth. That's because webhooks are triggered by Stripe, not by the user's browser. So we don't have access to the user session here. That's why we pass the user ID from the checkout session using metadata. So let's go back to our checkout API and pass the user ID inside metadata. Since I'm using Clerk, I can simply extract the user ID using auth and include it in the metadata. Now let's go back to the webhook and extract the user ID from the session metadata. Next we add a condition. If the user ID is not present, we return an error response because we need it to create the order. Next, we check for an existing order using the session ID. This helps us prevent duplicate orders. Then we add a condition. If the order already exists, we simply log that the order already exists and return a success response. Next, we get the line items from the Stripe checkout session using the session ID. But this is not enough. Along with the line items, we also need the product ID so we can correctly store each product in our database. Now, Stripe doesn't directly give us our database product IDs. So, to solve this, we pass the product ID from the checkout session using metadata. So, let's go back to our checkout API and inside the line items under product data, we add metadata and pass the product ID for each product. Now let's go back to the webhook and expand the product data inside the line items so we can access the metadata including the product ID. Now let's create an array to store our order items data. This array will hold the product ID, quantity and price for each item. Next, we loop through all the line items returned from the Stripe session. For each line item, we expand the product data so we can access full product details including metadata. From the expanded product, we check if a product ID exists inside the metadata. If the product ID is missing, we skip that item. This also helps us ignore non-product line items like GST or delivery charges, since we only want actual products in our order items. For valid items, we push the required data into our array. We store the product ID, quantity, and price and divide the amount by 100 to convert it back from the smallest currency unit. By the end of the loop, we have a clean array of order items that only contains valid products along with their quantities and correct prices. Now that everything is set up, we are ready to create the order in our database. We call the database and create a new order record. Inside the data object, we pass the user ID to associate the order using the logged in user. Next, we store the total amount from the Stripe session. We divide session.amount total by 100 to convert it from the smallest currency unit into the actual amount. Then we store the Stripe session ID as the Stripe ID, which helps us track and repress this payment later. We set the order status to paid since this is coming from a successful payment event. Finally, we create the order items using the data we prepared earlier. We pass our order items array and Prisma will automatically create all related order items linked to this order. By doing this, both the order and its items are stored together in the database in a single operation. Now let's fix this TypeScript error. After that, we log a message saying the order has been created. Finally, we send a success response with status 200 and a message OK. Now let's assign a proper type to order items data so TypeScript knows the structure of each item. This helps with better type safety and avoids unexpected errors. Also, instead of using the non-null assertion operator, we use the nullish coalescing operator as a fallback. This ensures that if the quantities are defined, it safely default to 1. Now, our webhook is completed. Next, we open the terminal and run Stripe login to verify our Stripe CLI. This connects our local environment with our Stripe account so we can receive webhook events. Now, we open the link shown in the terminal, enter the OTP and click continue. Then, we verify that the pairing code matches the one displayed in the Stripe CLI. Once confirmed, we click on Allow Access. After access is granted, we go back to the terminal. Now run the command stripe listen forward to localhost 3000 /API/webhook. This starts listening to Stripe events and forwards them to our local webhook endpoint. This command also provides a webhook secret. We use this secret to verify incoming Stripe events and ensure they are genuine. This secret is used in the construct event function where Stripe validates the request. Now copy the webhook secret and go to the .env file and add it as a Stripe webhook secret. And one more important thing, you need to run the stripe listen command every time in localhost. Otherwise, webhook events won't reach your local server and the order won't be created. This is only required in local development because Stripe can directly access your localhost. After deployment, this is not needed since your live server will be publicly accessible. Now, let's go to the browser and try ordering some items. The products are already added to the cart, so we will open the cart and click on Checkout. On the left side, you can see all the products along with the GST and delivery charges. Now, let's fill in the payment details and complete the payment. After successful payment, we are redirected to the success page. Now, let's switch back to the terminal. You can see all the webhook events are returning a 200 status code, which means everything is working correctly so far. Next, let's go to Supabase and verify whether the order has been stored. You can see the order in the orders table with all the details and the related order items in the order items table. This confirms that our webhook is working correctly and the full flow is successfully completed. You can then render these orders in the project based on the user ID. So this is our success page. I have already created an orders page. So when we click on view my orders, we can see all the orders and their items created by the user. And that's it for this video. We successfully integrated Stripe payments with Next.js and Supabase, handle webhooks and store orders in the database. If you found this helpful, make sure to like, share and subscribe. See you in the next one.